All right, so when we're looking at graphing, not graphing, and finding, again, the point of intersection, because it says solve the following systems, one of the reasons that we would find the point of intersection without graphing is they could be decimals, where you can't see it on the graph. Or I'm going to start with example 4 on my note. You get numbers that are really tough to graph, like this equation here, y equals 3x minus 32. Well, that has a y-intercept of negative 32. Well, I don't have graphs big enough for that. Now, here's the catch with this. Is that, again, I've said that when we have the point of intersection, you have the same x and the same y at the same time. That's key. All right, so that means this y here and this y here are the same at the point of intersection. All right, now, so at the POI, the point of intersection, these y's are the same. Right? And the x's are the same. Now, here's the thing. If these two y's are the same, and this is equal to that y, and this is equal to that y, then these two have to be the same. So, therefore, negative 4x plus 10 is equal to that y that I put with a purple underline there. But so is this one. 3x minus 32. At the point of intersection, they're both equal to that same y. They're both the same. And so if this is equal to the middle and this is equal to the middle, then they must be equal to each other, which means negative 4x plus 10 is equal to 3x minus 22. That is the big catch of today. So if there's any questions about that, now's the time to ask. That's the big catch.
Would it be 32 or 22?
Oh, thanks. 32. Thank you. Yeah, that's a 32. Negative 32. All right, now what we have is we have an equation where we can actually solve for x. And so I'm going to get all the x's to one side and numbers on the other. So I'm going to move this 3x over here, and I'm going to move the 10 over to with the negative 32. All right, so on my left-hand side here, I have negative 4x. The 3x is coming over, so again, change the sides, so it's a minus 3x. And over here, I have that minus 32. All right, and then the 10 is coming over, so it's switching signs too. It's a minus 10. All right, putting my like terms together, my minus 4x and my minus 3x together, that's a minus 7x. And, well, if I lose 32 and I lose 10, I'm down 42. All right, then I can solve for x by dividing by my numerical coefficient. All right, which is the number in front of my variable. And let's see here, these negative 7s, they divide each other out. And so x is going to equal negative divided by negative, going to give me a positive 6. So here's what we just found out. That is the x-coordinate of the point of intersection. All I need now is an equation for y, and then I can get the y-coordinate. We have two of them. Because they have the same x and the same y at the same time, I can use either of these equations to find the y-coordinate of my y-intercept. So it doesn't matter. I'm going to pick smaller numbers. I'm going to pick equation number 1 here. So I am going to sub x equals 6 into equation number 1. If you get bored, you can sub it into equation number 2. You're going to get the same answer because they have the same x and the same y at the same time with the point of intersection. All right, so now if I'm subbing into, I'm going to rewrite it here, y equals negative 4x plus a 10. I know that the x value is a 6, and so I have negative 4 times 6 plus 10. Y equals, let's see, negative 4 times 6, that's negative 24, plus 10. If I lose 24, but I get 10 back, well, I'm still down 14. But now I've got the y-coordinate of the point of intersection, and so my last statement, therefore, the POI, the point of intersection, is 6, negative 14. And there we go. And if you look actually at our second equation here, if you were to sub in an x value of 6, well, 3 times 6 is 18, minus 32, again, you would get negative 14 because they have the same x and the same y at the same time. All right, so let's try another one of those. We'll throw in some decimals this time, I think, or some fractions. All right, so I'll do, let's see on the sheet. I'm going to do example number 1. Let's go with number 1. Oh, there was my markers. All right, so on my note, I got, two equations. All right, the first one being, so it's example 1 on my sheet. We have y equals 0.5x plus 3. And my second equation here is y equals 2.5 times x minus 1. All right, there we go. So again, if I'm solving the following system, that again means to find the point of intersection. So that means at the POI, those two y's are the same. So I'll throw that down here again, but I'm going to skip a step. At the POI, all right, these two y's are the same. They're equal to each other, so that means these two guys have to be equal to each other. So I'm going to have 0.5x plus 3 has to be equal to my 2.5x minus 1. Because again, same x, same y at the same time. Well, here's what we got, an equation to solve for x. So we can find the x coordinate of our point of intersection. So again, I'm going to put numbers on one side. So I'm going to move that 3 over here, and the 2.5x is coming over onto the other. All right, so again, let's see, I got a 0.5x here. 2.5x is coming over, so it's a minus 2.5x. All right, on the other side here, I have a minus 1. All right, and then the 3 is moving over, so it's a minus 3. Okay, so now I have 0.5 minus 2.5. That's going to give me a negative 2x. It's like 50 cents minus $2.50, so I'm down $2. All right, and over on the other side, minus 1 minus 3, that's a minus 4. Again, dividing by a numerical coefficient. Let's see here. So those negative 2's divide each other out. Negative 4 divided by negative 2. That's a positive 2. There we go. All right, so now I have a choice. I want to find the y coordinate of my point of intersection. Again, I just need to substitute into either equation. I did number 1 last time. I'll do number 2 this time. So I'm going to sub x equals 2, because that's the x coordinate of my point of intersection, into equation number 2 this time, which is y equals 2.5x minus 1. Again, I know that my x value for the point of intersection is 2. So I got 2.5 times 2 minus 1. 2.5 times 2 is 5, and then minus 1. Well, 5 minus 1 gives us a 4. And so lastly, therefore, I've got the x coordinate, I got the y coordinate. So my point of intersection is, my x value is 2, and my y value is 4. That's where they meet. All right, so let's see here. Any questions at all? Hey, I messed that one up on my notes. I definitely did. Oh, I wrote it down different. All right, let's try one more here. Where are we gonna add? I'm gonna go with example 3. Actually, let's go with example 2. Let's go with example 2. Get some fractions in there. All right. All right, so example 2. Let's let's see here. I got two more lines here. I got y number 1 here. I got y equals negative 3x plus 11. And my second line that I'm talking about here, I'll throw a fraction here. We got y equals 1/2 x minus 3. There we go. All right, so this is something we've already, great thing about this is always the same. The POI. This y and this y are the same, right? Same x, same y, same time. I keep saying it. So if these two are the same, they're equal. That means these two guys are equal. So I got negative 3x plus 11 equals 1/2 x minus 3. Now, the reason I threw this example in, because we're just doing the same thing, is I got a 1/2 x. The only time I like to leave a fraction as a fraction is if I'm graphing it, because I want to know the rise and the run. But here I'm doing calculations. So this 1/2 x, I'm just going to rewrite it as 0.5x. Again, a fraction is just a divided by question that's not done yet. That's all it is. So all I did there was rewrite that 1/2 x as 0.5x because it's easier to work with calculations. But now I'm going to do the same thing as I've done before. I'm going to move my x's over to one side and move my numbers over to the other. All right, so I have a minus 3x. I minus a 0.5x because that 0.5x switch sides. On the other side, I got a minus 3. The 11 is going over, so it's going to become a minus 11. All right, so time to collect like terms. I got a minus 3x minus 1/2 an x. Well, I'm down 3.5 x's. And over here, I got minus 3 minus 11. That's minus 14. Okay, again, dividing by my numerical coefficient. Both sides. Negative divided by a negative. I believe I'm getting a positive, which is a positive 4. All right. And again, the last step, that's the x-coordinate of my point of intersection. I need to find the y, so I have to sub back into either equation. It doesn't matter. I'm going to go with the first one because I don't want to deal with fraction again, right? Let's go with number 1. So I'm going to sub in x equals, what do we have, 4 into the first equation. Again, I picked the first one. There's no fractions. And so that equation, again, is y equals negative 3x plus 11. And I found that x is actually equal to 4. So I plugged that 4 in there. And then now it's just the math. And so negative 3 times 4 is negative 12 plus 11. Well, if I lose 12 and I get 11 back, I am still down 1. And now, just about done. All I have to do is my therefore statement. Don't forget it for tests and quizzes. Therefore, the POI, the point of intersection, is our x value was 4 and our y value was negative 1.